Class 10, today I am going to start chapter number 3, that is based upon the pairs of linear equation in two variables. Now pair of linear equation in two variables is what type of equations? Let us see first, that if I am writing a1x plus b1y plus c1 that is equal to 0 and a2x plus b2y plus c2 equal to 0, this is the pair of linear equations and on two variables. So name of this equation is the pair of linear equation in two variable. Here two variable x and y, two variables are used here. So the equation is having two variable and it is coming in a pair, so that it is known as pair of linear equation in two variable. This is the standard form of linear equation in two variable. I am talking about the standard form of a linear equation in two variable. Here a1, b1, c1, a2, b2 and c2 represents any real numbers. That means at the place of a1, b1, c1 and a2, b2 and c2 you will have a real number. Any real number can be there, where a1, b1, c1, a2, b2, c2 and c2 are the real numbers, and x and y are variables. So this must keep in your mind always where you are dealing with pair of linear equation in two variable. Here what we have to discuss, what we have to learn, first of all here we have to understand the method of solving. That means the method of to get the solution of linear equation in two variables. We have to understand that how we can find the solution of such type of equations when we are having the equation in a pair. From there we have to discuss various type of methods here. Then first of all we have to understand graphical method, the first method which I am going to deal today, that is known as the graphical method to get the solution of a linear equation in two variable. In this method what you are going to do exactly, that first we will discuss upon that. First of all you have to write the equations. This is your first equation and this is your second equation. So each and every equation, for the first equation you need to find the solution set. You know that the equation is having more than one solution. That means a equation of which is having two variable may have many solution. So So, equation 1 and 2 are having many solution. Among that, you have to write minimum 3 solution. You have to write minimum 3 solution. For the first equation, you will be finding 3 solution. Then again, for the second equation, you have to find 3 solution. After finding the 3 solution of each, you have to take a graph sheet. In that graph sheet, separately you need to draw the graph for the equation number 1, and again on the same sheet you have to draw the graph for the equation number 2. Then if the two graphs are intersecting at a line, when your graph, you are drawing the graph suppose, and in that graph this is your x axis and this is your y axis. If you are plotting the graph and your graph, this is the equation number 1 graph, this is the equation number 2's graph, then if this graph is intersecting at a point, then this is the solution of the given equation. This point is the solution of the given equation. suppose here you are getting a point and just here down you are getting a point. Suppose this is the point x and this is the y. So the coordinate of this point will be x comma y, and this is the solution here. And sometimes that then you are getting one solution. This is the case for one solution. If the nature of graph is coming one solution, it is also called unique solution. Then when you are drawing the graph on a graph sheet for the two equations, then the graph is intersecting at a point, that means you are having only one solution, and that solution will be the point of intersection of these two graphs. And second case, you may have sometimes the case like that. In the second case, you may see that your graph may not intersect each other. The first and second graph is not intersecting at any point. That means the lines are parallel. In this case, you are having no solution. This is the here in this case you will have the no solution because the graphs are not intersecting at any point. And you may have the third situation, third condition, where you can see that your graph, one graph you have drawn. This is suppose for equation number 1, you are having 3 solution and you have drawn the graph and 3 points you are getting over there. Okay. Again, if you are going to draw the second equation's graph, this graph is also going on the same line. That means both the graph are going on the same line. In this stage, you can say there are many solutions. So this is the case for many solution. So here the point of discussion is that by looking at the nature of graph, you can decide that whether you are having a unique solution, means one solution, whether you are having no solution, or whether you are having many solution. That will come when you will draw the graph. But before drawing the graph also you can decide that whether the pair of linear equation is having unique solution, that means the one solution, that I am going to discuss now. First you copy down these things. Now I am talking about the standard form of linear equation in two variable, that you are having a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. So here in this stage, if you are getting one solution, that means the pair of linear equations are consistent. If you are getting many solution, that means also the pair of linear equations are consistent. And if you are not getting the solution, that means the pair of linear equations are inconsistent. So how we will decide? So first number, you have seen the graph which I have shown you, the first condition graph. You can check if a1 by a2 is not equal to b1 by b2. If a1 by a2 is not equal to b1 by b2, that means you are having one solution. You will have only one solution. So after writing the equations, you can check that how many solutions you are having, and it is a consistent pair. It is also known as consistent pair. Okay. So the first condition which I have shown you, this is consistent. This is consistent, consistent, consistent pairs. So after checking, you can, without drawing the graph, you can say whether the equation is consistent or inconsistent. Now the second condition, if you are having a1 by a2 is equal to B1 by B2 and it does not equal to C1 by C2, then no solution. You are having no solution at all. That means the graph, second number graph I have shown you, the lines are parallel. In this case it is inconsistent. You can write it is inconsistent. At this stage, if you will be writing the value of A1 by A2, then you are checking B1 by B2 and you are checking C1 by C2. If A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2, that means you are having no solution and the pairs of linear equations are inconsistent pairs. You can say that in this case equation is inconsistent. And the third number, when you are having A1 by A2 is equal to B1 by B2 and it is also equal to C1 by C2, then you are having many solution. And in this case the pair of linear equations are consistent. Consistent pairs. That means you have seen that the two cases you are getting for consistent. Okay. That means the consistent pair at the two cases, the case number 1 and case number 3 is showing for the consistent pairs and case number 2 is showing the relation for inconsistent pair, means there is no solution, and case number 1 consistent, the pairs of linear equations are consistent, but here A1 by A2 is not equal to B1 by B2. And the third case you can see A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then you are having many solution, and this is also the case of consistent pairs of linear equation. So these are the some important fact about this linear equations in two variables. So you have to note down it. Then we are starting the exercise now. Exercise 3.1. I am going to show you how you will be doing it, but you have to take the graph sheet. So whatever work you are going to do, that you need the graph paper, and graph paper you will be just tearing one sheet, solving it and pasting in your notebook. Means one graph for one question, the graph sheet will be pasted. First of all, write the solution that I am going to show you how you will be doing. This is exercise 3.1 which I am talking about today. Exercise 3.1, question number 1. You can see here in question number 1, the question is, Aftab tells his daughter, 7 years ago I was 7 times as old as you were then. Also 3 years from now I shall be 3 times as old as you will be. Represent this situation algebraically and graphically. Here algebraically means you need to write the linear equation, and graphically means you need to draw the graph of this equation. So here they have told you to write the equations for this relation and then draw the graph of this. So how I am doing? I am doing on board, but you have to do this question on the graph, but solution part whatever is there that you can write in your notebook, then draw the graph separately on a graph paper, then just paste in your notebook. So how I can start this question? So I am showing the solution. Let present age, whose age you will take first, then present age of Aftab. Let present age of Aftab, first, that is x years. Suppose Aftab's present age is x years, and present age of Aftab's daughter, and present age of Aftab's daughter is equal to y years. So the present age of Aftab and his daughter is written. So according to question, ATQ, according to question, what is given here? That 7 years ago, what was the age of Aftab? Now Aftab is x years, so 7 years ago Aftab's age was x minus 7 years. So this is the case for 7 years ago. This is the case for 7 years ago. Always you will see that there are two cases. So according to question, in the first case I can write also the first case. So 7 years ago Aftab's age was x minus 7 years and her daughter's age was y minus 7 years, but it is Aftab's age was 7 times his daughter's age, that means you need to multiply it by 7. So this is the case number 1. According to question, here you can write case 1. So I am taking some space there. You can write according to question. So this is case 1, directly I am writing this is the case 1, because here always you are having two cases. So this is the 7 years ago. Aftab's age, present age is x years, so 7 years ago his age will be x minus 7 years and daughter's age will be y minus 7, but Aftab is telling his daughter that 7 years ago I was 7 times as old as you were then. That means this relation will be created, and then just you settle down this one. This will be x minus 7 into 7y minus 7 7 ja 49. Then just x minus 7y, or I want to find draw the graph itself, so I can settle down this equation in this form also. X equal to, or they have told in the question that write it algebraically. So let us write algebraically first. X minus 7y minus 7, and this is minus 49 will come this side, it will come plus 49 equal to 0. So x minus 7y, and here that will be plus of that 42 equal to 0. So here you can see this is the first algebraic equation which you are getting by this statement. So algebraically the equation for the first case can be represented like this. So this is the equation for the first condition. This is the equation for the first condition, x minus 7y plus 42. Now you want to write its solution, and if I am searching for the solution, then I can write x equal to, now I am taking all these things right side, so it will be 7y minus 42. So in some questions it is written that just you write the equation first, or just you write the equation, no need to solve. So I have shown you the equation first. This equation is in the standard form, that because you can see the value of a1 is 1, the value of b1 is minus 7, the value of c1 is 42. This thing you have to keep in your mind. So after writing the equation, I can clearly understand that when I am comparing this equation with standard form, then I am getting the value of a1 here, that is 1, the value of b1 that is minus 7, and then value of c1 that is plus 42, that means 42 itself. And for the solution, now I am again arranging it, that will be x equal to 7y minus 42, and if you want to draw the graph, then you have to make a table. In that table you need to write the solution set, and minimum I have told to write 3 solutions. So here for y you can take any number, so that yx will come automatically. Suppose for x I am taking here the value 0, or for y, suppose for y I am taking 6. So 6 7 ja 42, so that I am taking value here 6. So 6 7 ja 42, and 42 minus 42 becomes 0, that you can see. If y is taken as 6, then x becomes 0. How? 7 6 are 42 minus 42 is 0. Then in second, now I am taking y as 0. If y is 0, so 7 into 0 becomes 0, and now you are having minus 42 itself. This is the second value, and for third value I can take any value of y. So this time if I am taking y as, suppose 1 I am taking, okay. So 7 1 ja 7 and 7 minus 42, then you can see the value will come minus 35. So like that, this is the solution set for first equation, and you keep this equation like that. So this is your first solution, first table for the solution set, and by taking this we will draw the graph later on. So this is the first part. Then again I am doing for case number 2. In second case, what is told in your question, for second condition is written that 3 years later, 3 years later, that means 3 years from now, I shall be 3 times as old as you will be. That means after 3 years. Case number second, it is talking about after 3 years. So I am writing after 3 years. What happened? Aftab's age will be x plus 3. Aftab's age will be x plus 3 and daughter's age will be y plus 3, but relation is given, then Aftab's age will be 3 times daughter's age. That means you need to multiply this by 3. Then again you can settle down the equation, that is x plus 3 equal to 3y plus 9. Then further it can be written as x minus 3y plus 3 and minus 9, that is equal to 0. Further x minus 3y and minus 6 equal to 0. So this is your second number equation, that is x minus 3y minus 6. This is the second equation which you have got. This is equation number 2. So now it becomes the pair of linear equation. One pair you have seen, the first pair is here and it has come from the first case, that means the first condition, and the second relation is coming from the second condition or second case. So x minus 3y minus 6 equal to 0. These two equations I have written in the standard form of linear equation in 2 variable, so that you can identify the value of here a2. The value of a2 is what here? If you will check that the value of a2 is 1, the value of b2 is minus 3 and the value of c2 is minus 6. Like that you can identify the value of a1, b1, c1, a2, b2 and c2. It will help you for the prediction that how many solutions are possible for such type of equation if asked in the question, or you may need in some questions. So here this is the second. Now I want to find the solution set for this second equation also. So again I am shifting it, x equal to 3y plus 6 I can write, then I can make a solution set for this equation also. So I have told you minimum you have to take 3 solutions for x and y. So here if I will take the value of y, then automatically x will come. So the first value of y, that is I am going to take a 0. If I am taking y as 0, then 0 into 3 becomes 0 and the value of x is coming 6. And then if I am taking x as minus 2, then 3 into minus 2 becomes 6. This will be minus 6 plus 6 becomes 0. So 2 values I have taken, then one more value of y I am going to take. This time I am taking 1. So 3 into 1 becomes 3 and plus 6, that is 9. So 2 tables you are having now. These tables are known as the solution set for linear equation in 2 variable. So for first equation the solution set you can see, and for the second equation you are having the solution set. As you are aware about this situation that a linear equation of two variable is having infinitely many solution, but for the graph we need at least, that means minimum 3 solutions. After doing this work, you need to take a graph sheet. Just I will show you here how you will be doing this on the graph sheet. So just you copy down till here. Then let us see how to draw the graph now. So now I am having these two solution sets. Okay, in this two solution set, this is the for the first equation and this is for the second equation. Now you on the graph sheet, you will be going in the middle of the page and you will be drawing the graph. This is x axis, right here x, and here x dash, this is y axis. So here you will be writing y and y dash. In the middle you have to see that in the middle there is a 0. Now depending on this value you can take your units. Unit you have to decide by yourself so that you can plot the graph very clearly and neatly over there. How you will be plotting the graph? Now you are aware about the graph. In your graph sheet sometimes you can see there are 5 division. So your graph are of two types. Sometimes you are getting the 5 division for a square and sometimes you are having 10 divisions for a square. So if I am taking a 5 divisions square, then I can set down here 5, 10, then 15, then 20 and then 25. This side also 5, 10, then 15, 20, 25, 5, 10, 15, then 20, 25, 5, 10, 15, 20 and 25. Just I am giving you the rough idea to draw the graph of these equations. So here I am considering that I am having a graph sheet with 10 divisions. So here I can write number 10, 20, 30, 40 and 50. This side also I am writing minus 10, minus 20, minus 30, minus 40 and minus 50. Here 10, 20, 30, 40 and 50. Add down, it is minus 10, minus 20, minus 30, then minus 40, then minus 50. So the numbers are taken and I am considering a graph which is having 10 divisions. That means the square, the biggest square is divided 10 lines, 10 small lines. So here for the first equation, if x is 0 then y is 6. If x is 0 then y is 6. 6 will be nearly coming at where I am showing you 6 will come. X is 6. X is here x is 0 then y is coming 6. That means the point may come here. So I am showing you the point here. And if x is minus 42, y is 0. That means x is coming minus 42. After 40 the point will come 42. Suppose x is minus 42 then y is 0. That means the point is coming here itself on the graph line. So 2 lines is there itself. Then if x is coming minus 35, x is coming minus 35, then y is coming 1. So it is nearly the point will come like that here. Now if I am going to draw the graph, I am going to join these 3 points, then I will have the graph like that. Just you consider, I am not using any scale over here because I want to show you the nature of graph. So your graph is coming, suppose like that your graph is coming. Surely it will be a straight line. Surely this graph for the first equation, whatever you are getting, that is coming is a straight line. Now in the same sheet, I am going to draw the graph of second equation, that is x equal to 6 and y equal to 0. So x equal to 6, then y equal to 0. The point which I will get this time, suppose my x 6 and y 0 is coming there. X, this is the point for that. Then x 0 and y is minus 2. Then y is minus 2. The minus 2 is nearly, suppose it is coming here. Okay, there is 0. So just I am showing you how you will be getting. If x is 9, then y is 1. X is 9, then y is 1. Then the third point, I guess it is coming nearly there. So again, if I will join these three lines, then the graph is nearly like that, the graph will go. So this is the for second equation, that means this is the for first equations solution set, this is for second equation solution set, and now you have seen the graph is coming like that. After plotting the graph, you need to write the point. First is 0 and 6 for the first equation, 0 and 6, then x is 0, x is 0 and y is 6. So the first point, suppose this is 0 and 6, you have to write the coordinate, then minus 42 and 0. Suppose this point is minus 42 and 0, then third point minus 35 and 1, minus 35 and 1. So you need to write this coordinates of these graphs. Then x 6 and 0. So 6 and 0, suppose this point is coming 6 and 0. I may write here 6 and 0, then 0 and minus 2. So 0 and minus 2 is coming this point. So this point here I can write 0 and minus 2. Okay. Then the third point 9 and 1 I can write over there. So I mean to say that after drawing the graph, you should write the coordinates also and just give a number for first. The first line is for the graph of the first linear equation, and the second line is the graph of the second equation's graph for the second equation. So here thus you have written the algebraic equations and their graph represented. So this is the graph, and by the number first and second, whatever I have shown you, that is the algebraic equations of this equation, because in the question it was written that represent this equation algebraically. So when you are writing the linear equation in two variable, that you have already written the equations algebraically, and then they have told graphically, that means you need to draw the graph. I hope that you have understood this, and further you are doing all other questions. Obviously I will show you few more questions of this exercise, but you have to try, because I cannot show you graph here on the board. I can just show you how to draw the graph, and you are aware about the graphs of a linear graph you have already drawn in your junior classes. So I think there is no problem, but here you may face the problem to decide the scales. So take the scale wisely according to the values, whatever solution is coming. First you check the solution, what type of values you are getting, then accordingly you decide the units, and once you will settle down the units, then you can draw the graph. So use your scale pencil to draw the graph and paste it in your classwork copy. So there are 3 questions are there in exercise 3.1. So one question just I have shown you, the remaining two questions, question number 2 and 3 I have given you as a homework. You must do this question. Thank you for today.